All right, so this lesson. I'm not gonna get super detailed with it because you watched the video on Friday and some of it on Thursday, and I even assigned the homework and everything. So we're just gonna go through just some basic stuff. All right, so I'm not gonna get real detailed. Just want to go through it, hit the words, and then you'll understand it. Oh, that's right, kite. Oh, we did talk about the kite, didn't I? Because I remember. All right. I don't know. I was so out of it Thursday that I barely remember anything that I did there. So let's talk about some different shapes of some quadrilaterals. What do I want to do first? Okay, let's do this. Oops. Let's change that to that. Let's change this to this. There we go. And I am going to slant this a little bit. Let's slant it like, I don't know, 30 degrees. There we go. All right, everybody ready? So we're classifying quadrilaterals. So first of all, what's a basic quadrilateral? Quadrilateral is any what? Four-sided figure, okay? And there's a bunch of different types of shapes, aren't there, for four-sided figures? There's not just one. Like if I asked your average kid in the hallway, I'm like, give me a quadrilateral. They'll probably say, what? What are you talking about? Four-sided figure. Give me a four-sided figure. What do you think most people are going to say? Probably square. Would you agree? But there are a lot more than just squares. Would you agree? Yes. So one of them is this. Is that a square? No, it's not. But if I know that those are parallel and these are parallel, then what do I call this thing? That's a what? A rhombus? That's a rectangle? It's not a rhombus. What do these arrows indicate? Perpendicular. Perpendicular means 90 degrees. They're parallel to each other. It means they're parallel to each other. Just because they're parallel to each other doesn't mean it's always a rhombus. Okay? But it's a, whoops, that's a weird looking P, isn't it? It's probably not much better. It's a parallelogram. Maybe it is a good thing we go through this again. You guys are acting like, oh, I got this, no big deal. Nobody knows the answers to this stuff. All right, so it's a parallelogram. What's a parallelogram? It's a four-sided figure, a quadrilateral, right, with both pairs of opposite sides being parallel to each other. That's what a parallelogram is. I'm not going to make you memorize the definition. I'm not going to have you write it down or anything else, but that's what it is. Okay, it's a quadrilateral with both pairs of opposite sides being parallel to each other. Everybody with me on that? All right, good. Now, we are going to discuss several different types of parallelograms. So that's just a general everyday parallelogram. But now we're going to get into some specific types of parallelograms. All right, and that's one of them right there. So this isn't just a quadrilateral. It's more specific. That's a terrible looking right angle. There we go. Yeah. And what do we call this thing right here? It's a rectangle. So rectangle is a parallelogram. Okay? So this is a parallelogram, right? But when I just draw a normal, everyday, average parallelogram, we usually draw it like this, okay, with a little bit of a slant to it. It doesn't always have to look exactly like this, a parallelogram. But you do know that the opposite sides are parallel. So what do we know about this? Since it's a parallelogram, what do we know about the opposite sides? They're what? They're parallel. But now, since we know it's a rectangle, there's a couple things that are a little more special about a rectangle than just an everyday, ordinary parallelogram, right? And that is what? Well, first of all, I put these little boxes in there. What does that mean? They're right angles, right? And so all these two sides are perpendicular, right? So it's got four pairs of perpendicular sides. So, so what is a rectangle? It's a parallelogram with four right angles. So if it's a parallelogram, let me see when I get, I was about to say something and I don't have that in my notes. Why didn't I have that in my notes? Maybe because there's a theorem that I haven't. Oh, is that why? No, I don't have it in my notes at all. I thought I should have had it right at the beginning. Well, I'm going to say it anyway. So watch this. Let's go back to this. So by definition, oh, you know what? Maybe it's in another. Oh, sorry. Maybe it's in another lesson. I think it is. Yes, there it is. It's in the next lesson. That's why. I'll give you a little sneak preview, though. All right. What is it? Now, this is parallelogram, right? So the opposite sides are parallel to each other. What else does it look like might be true about the opposite sides? They're congruent to each other. Exactly right. Okay. Now, we haven't learned it yet. We're going to learn it in the next section. Okay. But we will eventually learn that the opposite sides are also what? Congruent to each other, or you could just say equal to each other. All right? Does that make sense? So, what do you think you know about this? You got 4 right angles, but again, I'm getting ahead of myself. I really shouldn't do this. But in the next lesson, you're going to see that something else is true about the opposite sides. The opposite sides are also what? Equal to each other. Okay? They're parallel because it's a parallelogram. Okay? But they're also equal to each other. Anyway, again, I'm getting ahead of myself. Let's just keep going with this. So rectangle is just a parallelogram with 4 right angles. Everybody got it? All right, let's do another one. What if we did this? All right. Actually, let's not do that just yet. Let's do this. We'll take this like 20 degrees. Okay. And let's just make it so it looks like all 4 sides are equal to each other. Okay, so here we got a parallelogram again. Looks like an everyday, ordinary parallelogram, but look what I'm going to tell you about it. I'm going to say that this equals this equals this equals this. Everybody got that? Does that mean that's true on every single parallelogram? No, all 4 sides are not equal to each other on every single parallelogram. Look, this side definitely doesn't look the same as this, does it? All right, but on this one, it does. So I give this another special name. What do you think I call that? This is what I call a rhombus. Okay, when all 4 sides are equal to each other, it's a rhombus. Now, if a rectangle and a rhombus had a baby, then it would be a square. Let's keep that white. All right, so let's click on. There we go. So now, if I had a rectangle, but all 4 sides were exactly the same, then I would have a square. So a square is a rectangle. Would you agree? Why? Because it's a 4-sided figure with 4 right angles, and that's what a rectangle is. Agreed? A square is also a rhombus. Why? Because it's a 4-sided figure with all 4 sides equaling each other. Okay? So this combination of the two is considered to be a square. All 3 of those are what? What's the big thing? Well, yeah, quadrilateral, that's true. Okay, then under quadrilateral would be what? Parallelogram, right. So they're all quadrilaterals, that's true. All these things are quadrilaterals. More specifically, they're parallelograms. More specifically than that, this right here is a rectangle, and it's a what? Rhombus, and you put those 2 together, and you get a square. Everybody good? All right. Let's do one more of these. This, now we're done with parallelograms for right now anyway, okay? We're done with parallelograms. This next thing is not a parallelogram. All right, let's see if I can draw this. And let's do this. Let's copy and paste. So I'm keeping it the same length, but watch what I'm doing. I'm going to flip it Did I do that right? Should have flipped it the other way. Let's try this again. Yeah, that's right. I think I did it right the first time. Come on. There we go. Yeah, that looks good. And what I'm going to do is this. I'm not going to keep that middle line in there. I'm just doing it just so I can get everything lined up. Is that all right with you? So I'm just going to go to here. I'm going to go to there. We will deal with this line in the middle later on, just not today. All right, look at that thing. What's that called? That's a kite. Now, what's true about a kite? Is it a parallelogram? Are the opposite sides parallel to each other? There's nothing parallel to each other here, is there? Would you agree? All right, so it's definitely not a parallelogram, which means it's not a rectangle, it's not a rhombus, it's not a square, okay, but it is special. It's got a special name and a couple of things that are true about it. Watch. These two sides right here are equal to each other, all right, and then these two right here are equal to each other. There is nothing parallel on here at all. So here's the definition of it. It's a quadrilateral, all right? That's pretty easy to see. How do we know it's a quadrilateral? 4 sides, exactly. And it says 2 pairs of equal consecutive sides. So these are consecutive, all right? It's got 2 pairs of equal consecutive sides, but it says the opposite sides are not equal to each other, all right? So these 2 sides are next to each other. Do you see how they share that point right there? See these 2 right here? All right, and these 2 right here share that point, right? So they are next to each other, but the opposite sides are unequal. See, this side right here and this side right here would be opposite each other. They are unequal to each other, all right? So you got 2 pairs, exactly 2 pairs of equal sides. But these 2 right here next to each other are not equal. These 2 are not equal. All right? Make sense? All right. So that's a kite. We're going to learn later on more about a kite, just not right now. All right, let's do another thing. Another 4. This is still a quadrilateral, though, isn't it? Still 4 sides. 4 sides that make up a quadrilateral. Here's another quadrilateral, but it's not a parallelogram. And if you took notes on this when I was not here, you probably know this. I'll tell you what, I'm going to make it look like this for a reason. What is it? Trapezoid. Exactly right. Did I write down the word kite before? Didn't write it down, did I? I should have written it down at least. So this is a kite. Go fly kite, right? All right, this thing, let's write it down. It's called a trapezoid. Trapezoid. It's quadrilateral, but it's not a parallelogram. Why is it not a parallelogram? Look, this side is parallel to this side right there. Isn't that enough to be a parallelogram? No. What else has to be true about it to be a parallelogram? The other 2 sides got to be parallel to each other as well. Okay, this has exactly 1 pair of parallel sides. Exactly, not at least, parallel sides. What am I doing? There we go. Okay, exactly 1 pair of parallel sides. These 2 right here are the ones that are parallel to each other. These 2 are definitely not. Okay, if these 2 definitely are not, and these 2 are, then it's a trapezoid. We got names for some of these sides. The 2 sides that are parallel to each other, do you remember what we call them? Call it a base. I'll put a base 1. Is that all right? Because at some point, I forget when, but at some point you're going to find the area of this, and that would be the 1 base. This would be the 2nd base. All right, it doesn't matter which one. Oops, put a 2. One would be base 1, the other one would be base 2. It doesn't matter which one, the longer one, the shorter one, it doesn't make any difference. One's called a base, the other one's called a base. What about the two sides that are not parallel to each other? We call those legs. Okay, so that's a leg, and that's a leg. Everybody good with that? Yeah, pretty easy. Alrighty. Let's draw another thing. Still a trapezoid, but what do you think we're going to draw now? It's probably next in your notes. Anybody see it? This may not be 100% drawn to scale, but it's pretty close. It's a little bit off, but it's pretty close. We'll say it's good. We'll say it's a trapezoid. So this and this are parallel to each other. There's something special about this trapezoid that really wasn't that special on the other one. On this one, this side is equal to this side. Doesn't mean they're parallel to each other now, though. No, of course not. It slants up like this. There's no way those two sides right here are parallel to each other. But they are equal to each other in length. A trapezoid, what's a trapezoid start with? T, okay? What's something else that we've talked quite a bit about in the past? We're going to talk more about. This starts with a T. Triangle, okay? Trapezoids share some similarities to a triangle, not just the T, all right? Do you remember if you had a triangle? I'll just draw it by hand. If you had a triangle and two of the sides were equal, do you remember what we called that triangle? Isosceles trapezoid, or give it away. This is an isosceles triangle. So look at this. If I took this side and I extended it way up here, let's what if I took this and I extended it all the way up here and I extended it all the way up there? I could make a triangle out of that, couldn't I? All right. Now it's not. It's kind of like a triangle, but we kind of cut off the top of it. All right, if you think of it that way, that's kind of what a triangle is, or a trapezoid is. Watch, if I cut that off, what do I have? Got a trapezoid, don't I? You see that? So if I cut it off flat, okay, parallel with the base of it, the bottom of it, then I'd get a trapezoid. Anyway, we'll talk more about that at some other point. But I call this an isosceles triangle, so what do you think I call this? An isosceles trapezoid. All right, how do I know if it's isosceles? Because the two legs are what? They're equal to each other, okay? If the two legs are equal to each other on a trapezoid, then it's an isosceles trapezoid. We're going to learn about some stuff about an isosceles trapezoid a little bit later. Let's see. Yep, we're going to learn about it a little bit later. All right, I think that's all the labeling of things that we're going to do. Now let's do a little bit of work, and then we're going to learn something else. So let's go back to the kite. They do an example with the kite. So let me try to draw a good kite. I'm going to copy and paste that. I'll flip it. There we go. Let's put that about right there. And then draw this. Don't draw that middle line again. I'm just doing it just for reference so that I can go from here to here. And then I can go from there to there. Like I said earlier, we will talk about that line. We will connect those and talk about what it is and all that kind of stuff, but not today. So here's my kite, and here's an example. I probably did this on the video on Friday. Do you have this in your notes? Okay, good. Again, this may not be drawn to scale. Like the side that looks shorter on here may actually be a longer side. All right, so don't worry about that. We're just worried about the numbers. All right, so if this is a kite, I told you this was a kite, whatever you want to call it. A, B, C, D, or whatever, okay, W, X, Y, Z. If I said this is a kite, you should know that a couple things are equal to each other, agreed? These adjacent sides. Now, does it look like this one here and this one here are equal to each other? Now, they are next to each other, okay? They are consecutive, one after the other, but these are the ones that are not equal. Remember, the opposite sides are definitely not equal to each other. So these two sides are not equal, these two sides are not equal. That means that this side and this side are equal. So I'll put a one tick mark there, one there. Then this would equal this. And now I just want to solve for x and y. Pretty basic and easy, so let's do it. So let's just set these equal to each other. Let's distribute this in our head. What's that going to be? 3y plus 6 equals 5y plus 2, yeah? Subtract 3y from both sides, I get 2y. Subtract a 2 from both sides, I get a 4. Divide both sides by 2, y is 2. So what's the length of either one of these sides? Let's put it into this one. 5 times y, 5 times, well, 5 times, I'm sorry, yeah, 5 times 2 is 10 plus 2 is 12. All right, so that's 12 right there. Without doing any math at all, what should this be? This should be 12, right? Let's see if it is. Put a 2 in for this. 2 plus 2 is 4 times 3 is 12. Yep, sure enough. Now, just with that information, could we find this? No, you got to know something about these. These are equal to each other, so let's set them equal to each other and solve for x. So it's pretty easy. We could pretty much skip this, but I decided to do it. Subtract an x, 2x, add a 1, 6, divide by 2, 3. See it, 3 plus 5 is 8. So that's 8. Of course, this would be 8 as well. If you wanted to, you could plug it in. 3 times 3 is 9, minus 1 is 8. That's 8 as well. That stuff's super easy now, isn't it? That you've seen that a bunch. Maybe in the video, did I do the thing with the... can't think of anything. When I did the rectangular coordinates and I put the points, did I do that? Did I do example 3 on the video? I can't remember. I didn't actually watch the video anyway. Anybody looking at your notes? Did I do example 3 where I did like this, an x and y axis, and I plotted some points? Like, so I never did this? And then you had to find this? Okay. Well, I'm going to skip it again. I probably should do it. But I just want to get to some other things. All right, let's flip the page over. All right. I don't know why, but this is one of the things I enjoy teaching. I just think it's interesting. I think it's kind of cool that you can figure this stuff out, which kind of always blows me away a little bit. Watch. I'm going to draw a quadrilateral. It's not going to be any kind of special. It's not a trapezoid. Almost starts looking like a trapezoid, but it's not quite. It's not a trapezoid. It's not a kite. It's not a parallelogram. It's just a basic, everyday, four-sided figure. Okay? Now, what I'm going to do, and I'm pretty sure I did this on the video. I usually do. What I'm going to do is I'm going to split this. I'm going to go from this point to this point. I have a name for that. Anybody write that name down? That yellow right there starts with a D. No, it's not a diameter. You didn't write that in your notes? I must have said this in the video, didn't I? It's called a diagonal. Here's what we're going to do. We start from any vertex. I don't care what vertex you start at. I just started right here. I just picked it. Just random. Okay, just pick that vertex. And then what I did is I drew a line from that vertex to another vertex that's not right next to it. Hear what I just said? Okay, so I started here. I'm like, okay, I'm going to draw a line to another vertex, but I can't draw to the one right next to where I started. See how that would be right next to it? And this would be right next to it? What's my only choice? to go to here. So that's called a diagonal. That's what a diagonal is. It goes to a non-consecutive vertex. Hear my words? Non-consecutive, which means not the one right next to it, because right next to it would be the consecutive vertex. Everybody got it? So that would be a non-consecutive vertex. So that's a diagonal. So once I do that and I drew that, how many triangles now do I get out of this? There's one triangle. There's two triangles. Okay? What I'm trying to do now, we're kind of switching gears a little bit. Well, actually a lot of it. We're switching gears. What I want to do is I want to find what all the angles of this quadrilateral are going to add up to be. All right? Now, I already know how many degrees the angles of a triangle add up to be. We've talked about that not too long ago, right? So how many degrees, I should say, do all the angles of a triangle add up to be? 180. I was watching a video the other day, just some YouTube video, and this guy was doing a reaction video to somebody else's video, and the video was about, I don't know, are you smarter than a high school kid or something like that, right? And then so it was like 50 questions. Some were kind of tough. Most of them were fairly simple. But one of them said, what is the sum of the angles of a triangle? And the guy that was reacting to it was a British guy. And he was like, what? How are you supposed to know that? Nobody in high school knows that. And I was like, oh, come on. You know, you guys are in, what are you, 9th grade now? 9th grade, and you already know that, right? And this kid, he'd graduated from college and everything. He was still fairly young. He was probably early 30s, maybe not even 30 yet. But he's like, he just couldn't believe that anybody would know what the sum of the angles of a triangle are, right? And I was like, yes, people in high school do know that stuff. And you know it. It's how many? 180 degrees. Okay, so what we're going to do, though, is we want to find out the sum of the angles of all the angles in this quadrilateral. So if I found out all the angles inside this triangle right here, how many degrees would be in this triangle 1? 180. How many degrees in this angle or this triangle 2 right here? 180. Okay? So what do I do to find out the total number of degrees in that quadrilateral? I add them together. That's right. So I just go 180. Instead of adding them together, what would be a little bit easier? Multiplying it by 2. All right, and that gives you, and I heard it already, but you guys said 360, okay? In any quadrilateral, doesn't matter what the shape is. It could be a parallelogram, it could be a trapezoid, it could be a kite, it could be just a random quadrilateral like this one. This isn't anything special. But every single quadrilateral, when you add up all the 4 angles to that quadrilateral, it's always going to add up to what? 360. A triangle is 180. And then a quadrilateral is 360. What I want to do is I want to establish a little pattern. Okay, so let's do another one. So that's not us, right? So 1, 2, 3, 4, 5. Okay? So check this out. What do I want to do? What's my end goal here? It's to find out how many degrees are what? Well, this isn't a quadrilateral. In that shape, how many sides do I have? 1, 2, 3, 4, 5. So it's a what? It's a pentagon. It's a pentagon, okay? So what I want to do, what I want to do is break it up into some triangles, right? So if I know how many triangles I have, then I can do what? Just add up all those triangles, right? The 180, 180, 180, whatever, how many triangles I have, and then I can figure out what the total number of degrees are. I can start anywhere. It doesn't matter what vertex. I don't know. Let's start right here, all right? Draw to a non-consecutive vertex. So does that mean, can I draw it to here? Is that a diagonal? Nope. I could draw one here. Then go back to that starting point and then draw it to here. Are there any other diagonals I can draw from that one point? No. Okay, it's all I can do. How many triangles do I have? I got 3. So guess what I do? I go 3 times what? 180, and that gives me 540. So on a pentagon, any pentagon, it doesn't matter what the shape of the pentagon is, as long as there's 5 sides, if you add up all the angles of a pentagon, what are you going to get? 540 degrees. Let's do one more. And then we're going to try to establish a little pattern. All right? So let's go 6. So there's 1, 2, 3, 4, 5, and 6. Okay? Everybody okay with that? All right, so what are we going to do? Draw what? Diagonal. So start anywhere. I'm going to start right here. It doesn't matter what vertex you start at. You'll still get the same number of triangles. Where do I draw? To there, and then to there, and then to there. Do you agree? How many triangles do I have now? 1, 2, 3, 4. So this is a what? Hexagon, isn't it? 6 sides. So what do? 4 times what? 180. And that equals, that's 360, and 360, that's 720, right? Would you agree? Can you do that in your head? Can you do that in your head? Watch. Here's how I did in my head. Everybody watching? It's not that hard. Split this in half. Split 4 in half. What's that? 2. What's 2 times 180? 360. And then another 360 would be another 2. So 360 and 360 is 720. All right? It's not that hard. So let's establish a pattern. All right? So one triangle equals 180 degrees. Agreed? 3 sides. Okay, so if I have 3 sides, I get 1 triangle. What if I have 4 sides? I get 2 triangles, don't I? So 2 triangles, and that equals 360, right? Then what if I had 5 sides? How many triangles did I get when I made 5 sides? I got 3 triangles, didn't I? And what did I get there? 540, okay? Then I did 6 sides, I'm sorry. So 6 sides. How many triangles did that give me? Give me 4 triangles. And that gave me what? 720? Let's do some more. What if, let's skip. That's an arrow. What if I went to 10 sides? Now let's go 8. Because we see 8 a lot. Skip 7. Okay. What if I go to 8 sides? How many triangles am I going to get? I'm going to get 6 triangles, right? See, 1, 2, 3. If I had 7, it would be, well, 6 was 4. And then if I had 7, it would be 5. 8 would be what? 6. What am I doing to the number of sides and the number of triangles? I'm subtracting how many? 2 from each of the sides. Everybody see that? So 3 minus 2, 4 minus 2, 5 minus 2, 6 minus 2, 8 minus 2, right, which is 6 triangles. I should know this off the top of my head. 1080, is that right? Yeah. What if I jumped all the way down to, I don't know, let's say 12 sides? How many triangles would that give us? It'd give us 10 triangles. And so how do I know how many degrees? What would I do? 10 times what? 180, right? That's what I got. That's how I got the 1080, isn't it? 6 times 180. And then 10 times, what's that? 1800 degrees. Okay. What if I had, I don't know, I'm going to be stupid, 347 sides? All right. It's kind of weird. What if I had 347 sides? How many triangles am I going to get out of that? 340 what? 5 triangles. So how do I find it? I don't know what that is off the top of my head. It's going to be some big number. 345 times what? Times 180, whatever that is. Okay, and that's how many degrees are in something that has 347 sides. 62,460. There you go. Not a number I don't think I've ever seen. So there you go. That's how many degrees would be in a triangle with that many sides. I do know that. That's kind of cool, isn't it? Do you understand why I like teaching this? So they have a little theorem. They call it the, oops. Let's try this again if I could. They call it the angle sum theorem. Angle sum. Why the sum? What's that? So when you add them all up, okay, if I add them up all together, that's the angle sum theorem. Now, they use the letter n. They use the letter n to represent how many sides we have, okay? So like the 347, that would be n. Would you agree? The 12 sides, that would be n. The 8 sides would be n. So how do I find the sum of all the angles? The sum of the angles of a polygon with n number of sides. This is what I do. I just go n. What did I do? I took the number of sides and I did what to it to get 10? What did I do to it to get 6? What did I do to that one to get 4? What did I do to those number of sides? Subtracted 2. And then after I subtracted 2, what did I do to that number? Multiplied it by what? 180 degrees. And that right there is our little formula to find the sum of the angles of any polygon. Does that make sense? Okay? That's it right there. Write it down. If you didn't write it down earlier on Friday, write it down now. Okay, the sum of the angles, excuse me, the sum of the angles of any side or n number of side polygon, this is how many degrees it's going to be. Okay, that's the degrees right there. All right, what if, we're almost done. I'm going to go to this. I got this little polygon tool, and it gives you 6 right off the bat, so let's just use that. What if this is a regular polygon? I've used that word before. What does that mean to be a regular polygon? This is regular. This is not just any random 6-sided figure. Okay, this is a regular 6-sided figure. So there's a lot of things that aren't perpendicular. It doesn't make them regular. All the sides are equal, right? And also what? What does it look like? Look at every single one of these angles. What does that look like? They're all equal too, okay? So if it's a regular polygon, must means all the sides and all the angles are equal to each other. So here's what I want to do. There's 6 sides here, right? What I want to do is I want to find just one of these sides. We'll call it x. We'll put a degree there. I want to find what that angle is right there, and that's all I tell you. All I tell you is this is a regular 6 sides is a what? What's the name of it? 6 sides. It's a hexagon. Thank you. So regular hexagon. And I want to tell you what each of the angles is equal to. Because they're all the same, right? Because it's regular. If it's regular, all the angles are exactly the same. So what could we do? Well, this is x. What's this angle right here? That's x. What's this one? X, 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 and x. How many x's do I have? I got 6, right? 6x equals, what do they all add up to be? Well, how do I do that? What do they all add up to? N minus 2, what? Times 180. You with me? How do I find x? Get rid of that 6. How do I get rid of the 6? Divide it by 6. So this is how I find that angle right there. Can I do that? Yeah, because I do know n, right? What's n? It's 6. There's 6 sides. So 6 minus 2 is 4 times 180, and you divide that by 6. What did we say 4 times 180 was? We did that earlier. Did it in our head. I showed you how to do it in your head. 720. Oops, that's ugly 7 looking. 720, right? And then what do? Divide it by 6. What's the 720? The 720 means all those angles, all 6 of those angles add up to 720 degrees, correct? So if I want to find each one of them and they're all exactly the same, I just divide it by 6. So what's 720 divided by 6? What's 72 divided by 6? It's 12, right? So it's 120. So each of these angles is 120 degrees, okay? What if you pulled up to a stop sign? Okay, you pulled up to a stop sign and you always wanted to know this. I'm being a little facetious here, okay? Just kind of joking. So what if you pulled up to a stop sign and you wanted to find out what the angle was of each corner of a stop sign? Well, what would you do? Well, let's figure out what all the angles add up to be. What do all the angles add up to be? So it's 8 minus 2, which is 6, times 180. And then what do you do with that? Divide it by how many angles do you have? How many angles in a stop sign? There's 8. 8 sides, 8 angles, correct? So that's your math right there. 6 times 180, what did I say that was? 1080? And if you divide that by 8, you get 135 degrees. What did I just find? I found the angle of a stop sign because a stop sign is an octagon, correct? 8 sides. How did I get that 6? What did I do to get that 6? I just did it in my head. But what did I do? I went 8 minus 2, didn't I? All right? So there's the n minus 2 times 180. That gives me what they all add up to be. Okay, if you added up all 8 angles, it would add up to 1,080. But then I want to find what each individual angle is. Just divide it by 8, because they're all the same, you get 135 degrees. So if you happen to have a protractor with you, and you pull up to a stop sign, jump out of the car, Mom, hang on a second, I got some important work to do. You put the protractor up to the stop sign, right? Now, I'm just kidding. Don't do this and get in a car wreck because you're being silly, all right? But if you did, you put a protractor up to a stop sign, and you're going to find out that that angle is 135 degrees. You could do that with any of them, all right? What about a 4-sided figure, quadrilateral? Do that in your head. I mean, you should know what it is already. If it was regular quadrilateral, that means it would be a what? We talked about it already today. What's a regular quadrilateral? It's a square, right? Because all the angles and all the sides are equal to each other. So we know it should be 90. Let's see if it really is. So let's go n minus 2. 4 minus 2 is 2 times 180. Agree? So what's that? 360. How many angles do we have? We got 4 of them. What's 360 divided by 4? 90. And that's why every angle in a square is 90 degrees. Isn't that cool? Yeah, I think that's kind of interesting. Well, there's basically a couple more, not really, there's one more thing we didn't hit. But I'll just give it to you. I'm not going to go, it was probably, I probably did it in the video on Friday. You tell me if I did or not. Only got a couple minutes, so let me just do this. If I did this, if I did that, okay? Now, check this out. What if I take each one of these sides and extend it? See what I'm doing? I took that side and I'm going to extend it. Take this side, I'm going to extend it, and let's take this side and I'm going to extend it. Don't lose me. Do you see these exterior angles that we made here? I'm not going to show you why right now. I think I did a little bit on the video that you watched on Friday. All of these angles right here, angle 1, angle 2, angle 3, they all add up. The exterior angles, these are exterior angles, agreed? The exterior angles of any polygon, it doesn't matter that it's 3 sides, 4, 5, 6, 7, 8, 9, 1,000 sides, it doesn't matter. That all of the exterior angles are always going to add up to the sum, I should put. the sum of the exterior angles are always going to add up to the same exact number, and that is 360 degrees. And that's kind of interesting. All right, I think it is. Like if you had a five-sided figure and extended all five sides, all the outside angles are all going to add up to 360. It doesn't matter how many you have. Remember, these are exterior angles. Okay, the stuff we did earlier were what kind of angles? Interior angles, okay? So these all add up to 360 degrees. All right, if you did not finish 6-1A and B, okay, that will be due tomorrow, and I'll collect those from you tomorrow, okay? I think most of you already have it done. Is that correct? All right, so make sure you get them done if you didn't, and then I'll collect them tomorrow.